Okay, so here we're going to take the Arty Z7-20 board created by Digilent. The board costs around $300. If you're on a slight budget, you could buy the lower model for $200. So we're going to start Vivado. And we're going to create a project. Now, under boards, if you don't see the Arty Z7 board that you have, click refresh and it's going to connect to GitHub and download the latest version. So I choose the Z7-20 because that's the board that I have. And after the project is created, I'm going to create a block design. I recommend you leave it named as is, design_1. And we're going to add some IP. We're going to add the Zynq processing system. Now, if you're using a different board that doesn't have a Zynq processing system, you would have to pick the Microblaze or the Microblaze MCS, which is a stripped down version of the Microblaze. But we don't have to worry about that over here. We're just going to add the Zynq, which is faster because it doesn't have to actually synthesize a device. As you can see, I'm dragging the switches and the 4 LEDs. This is not required for this project, but I just, out of habit, always drag them on there. Many times it's a way for me to debug a system to say, okay, is everything working? Is it running my latest code? If you scroll down, you see over there that I'm trying to connect the pmod-JA connector, and it says cannot find IP. So we're going to go to the IP catalog, and we're going to add a repository. This repository you can download from GitHub. It's called Vivado Library. I'll post a link down below. So we're going to add this repository. It's basically going to have the pmod-AQS and a bunch of other pmods, I2C chips. I don't know. So now we're going to go back to pmod. We're going to right click and say connect board component. Scroll down to pmod-AQS and click OK. So now if we go back to the diagram, let's see. You'll see that it added some IP. We're going to run connection automation, so it connects it to the Zynq via the AXI interconnect. We're gonna, let's see, save everything, and then we're gonna click validate design. Now we're gonna go to our sources. We're gonna click on the design, and we're gonna create an HDL wrapper. We're gonna let Vivado automatically manage this because we don't want to do that ourselves. Now you have to wait a little bit for Vivado to catch up. And now we're going to right click on the design and say generate output products. It's taking longer than I expected, but it's okay. Don't worry about these warnings. It's basically saying the pmod-AQS was built in an older version of Vivado, and we're using a later version. So now we're going to add a constraints file. I just call it cons. Then we're going to open the file. It's going to be blank. Now the best thing to do is go to GitHub, get the master constraints file. I have a link opened up here, but you see I just go to a new tab, and you just Google the board, and you say the word master constraints file, and it's going to come to the same one. So look, Arty Z7-20 master constraints file. First result. We're going to click copy entire file and paste it in. So now everything is commented out. For components such as the LEDs and the switches, they're automatically handled by the board drivers, you could say, but not for the pmod. So we're going to copy one of these and we're going to search for pmod. I like to scroll up and down. Of course, you can use the search function just so I could see everything that's in the file. So there it is, pmod header JA. I'm going to uncomment every single line because there are 8 pins. All the way to the right, you can see there are comments as well. That way, you know for sure that you're using pin 1, pin 2, pin 3, etc. Now, you'll see that your pmod actually has 12 pins. Pin 1, 2, 3, and 4 are used by us. 5 and 6 is for VCC and ground, and that's for the top row. On the bottom row, pins 7, 8, 9, 10 are available to us, but we're not going to use them. And 11 and 12 are, again, VCC and ground. So we have the constraints file set up. Now we're going to click Generate Bitstream. This is going to run synthesis, then it's going to run implementation, then it's going to generate the bitstream. And when it's done, we're going to export this to Vitis. We're going to program the FPGA from Vitis, and then we're going to run code on there. So this is going to take some time, so I'm going to speed the video up here. Okay, so we're back. So now I clicked on Open Implemented Design. You don't really have to, but if you do, you're going to see what's it called? It's going to show you the actual FPGA itself, the resources, and you can actually drill down and see the netlist. But I'm not going to do that right now. So instead, what I'm going to do is I'm going to export the hardware. I'm going to include the bitstream. And what this is going to do, it's going to create a hardware platform specification file with an XSA extension, which can be used by Vitis. And don't forget, Vitis used to be called SDK. It still uses Eclipse under the hood. So now I launch Vitis, but before I do that, I'm going to make a directory called SDK. In this directory, that's going to be the workspace for Vitis. If you're familiar with Eclipse, you'll know that every project has a workspace. So Vitis is waiting for me. I have to pick the directory. I believe it's pmod-AQS SDK. AQS SDK. Alright, so the first thing we're going to do is we're going to do File, New. Here we go. File, New, Platform Project. We call it whatever we want. I just call it Plat. And then we're going to specify the XSA file. We have to browse to it. Older versions of Vivado were much better at this. It would like automatically pop up and say, oh, design one wrapper. If you look at the operating system, it does have an option to add Linux or some other real-time operating system. And this is a dual core processor, so you can even pick the second core. So if you drill down into this pmod directory, you'll see that it comes with an actual example of using the pmod. So we're going to create an application project. We're going to pick our platform, and I'm going to call it pmod demo. You can leave the defaults for everything here. Okay, so we created the application. We're going to find the source file, hello world.c. Just remove everything or comment it out, whatever you prefer. All right, so now we're going to go and we're going to take the example main. We're going to copy and paste the text in. Then we're going to take all these source files except for the make file. Right click, copy, paste it into the same directory as hello world.c. Now we're going to click project build. Don't worry about the warnings. They could really use a linter or text formatter. Okay, so our code is built. Now we just have to run it. So the first thing we're going to do is going to click program device. It's going to automatically detect it. It's going to load the bit file without the source code. The bit file is the netlist. Now you can click debug as. You can use a regular debugger or you can use the GDB debugger. I've had success with both. Can't really say which one's better. However, the first time I ever run an application, I always run into issues. So we open the debug perspective. Something should appear under the debug, but nothing is there. So I click around and always struggle the first time. Anyway, terminal is how you can connect to the hardware device and read what's printed out. You can even use scanf or get char with it. We're not going to do that here. All I have to do is pick serial, and there should be one of the COM ports should be populated because Xilinx detects that for you. Pick the 115/200 baud rate, and now we are connected to the device, but we're not running the program yet. So click debug as. No, not there. How about here? Right click on the project and say launch hardware, and I think we got a connection. Programming FPGA, very good. All right, the program's running. So now you click resume. But before you do that, again, go to Window Terminal, connect to COM5, pick UTF-8. I find it much easier to use. All right, so now we're going to click resume. And there it is. Wait a couple of seconds for it to initialize. There we go. 400 parts per million CO2, 1 part per billion VOC. Now I'm going to show you a video from my cell phone of this actual device. Notice how I breathed into it and the ppm for CO2 went up. Anyway, stay tuned. All right, so here's the Arty Z7 Model 20. This over here that's pmod-A. Here's the AQS sensor. So we're going to plug it in to the top port. Let's see if I can get you guys a nice view. See, the pins go into the top. There we go. All right. Thank you for watching.